Question 1. So we've got to write down the modal class. This is the frequency that happened most often. So our biggest frequency is 27. What class did that apply to? Well, it applied to this number of days. So you just literally copy this bit down here. So D is greater than 12, less than or equal to 16. Now for part B, we've got to work out an estimate for the mean number of days. Now the number of days, we've got an interval here. We know that on 16 occasions, the number of days the car was in the car park was between 0 and 4 days. On 18 cars were between 4 and 8 days. But we don't actually know how many days the cars were in the car park for, just that it's between 0 and 4, or 4 and 8. So the best we can do is make an estimate. Now the estimate that we take is the midpoint. So what's halfway between 0 days and 4 days? Well, that's 2 days. Halfway between 4 and 8, and that's 6, and so on. So we estimate the number of days as being the midpoint, and then we use that. So we say those 16 cars were parked for 2 days, those 18 cars were parked for 6 days, etc. And then we then just cross multiply to work out the number of days in total. So 2 times 16 is 32, 6 times 18 is 108, and so on. We add up these total number of days to get 1068 days, and that's stretched across the 100 cars. So to estimate the mean number of days is 1068 divided by 100, which is 10.68 days. Question 2. Well, we're told the volume of brick A is greater than the volume of brick B. How much greater? So clearly we're going to have to work out the volume of A, the volume of B, and work out the difference. So to work out the volume of A, well, it's a prism, so it's the area of the cross section, the n bit multiplied by its depth. Well, the n bit is a triangle. How do you work out the area of a triangle? It's half times base times height. So half times 6 times 6, and then multiply this by the depth of the prism. So half times 6 times 6 times 5, which is 90. Now for part B, this is a half of a cylinder. So the volume is going to be half it would be for a complete cylinder. So that's where the half comes from. Now again, how do we work out the area of a prism? It's the area of the cross section, the n bit. Well, if it was a cylinder, the n bit would be a circle. To work out the area of a circle, it's pi r squared, and then we multiply that by the depth of the prism. So half, because it's half a cylinder, pi r squared, the area of a circle, and the depth of it. Now we're told that that length is 6, the diameter of 6, the radius is half of this is 3. So it's half times pi times 3 squared, the radius squared, times the depth of the prism, which is 5. Popping that into a calculator, we get 45 over 2 pi. Now we're being asked to work out the difference between the two, so it's 90 take away 45 pi over 2, giving us 19.314 ... So to one decimal place, that's 19.3 centimetres cubed. Question 3, part A. Well, we've just got to work out the nth term expression. So step 1, we see how much we're going up or down by each time. We're going up by 6. So the first term of our expression is 6n. And then the adjustment we have to do is the 0th term. What would be the number if you added 1 to the front of the q? So what number would be here in front of the 10? Well, reading right to left, we're going down in 6's, so we take 6 away from 10 to get plus 4. So our nth term expression is 6n plus 4. Now for part B, we've got a brand new sequence, and we're just trying to find some numbers which are in this sequence as well as the original sequence. So let's just start putting the sequence together. So position number 1, what would be first in the queue? That's when n is 1. Substitute 1 into this. 1 squared is 1, take away 3 is minus 2. What about the second position when n is 2? 2 2's are 4, 4 take away 3 is 1. Third position, substituting 3 in, we get 9 take away 3, which is 6. Fourth position, 4 4's are 16, take away 3 is 13. But the fifth number in the sequence would be 5 squared, take away 3, which would be 22, and that is in both sequences. So that is an example of finding one of these numbers. Other numbers exist, for example, our number 46, but there are others. Question 4. So on Sunday he walked 7% more steps than on Saturday. How many steps did he walk on Sunday? So we can do this using a multiplier. As we've got a 7% increase, our multiplier is going to be 1.07. So 10,800 multiplied by 1.07 gives us 11,556 steps. Question 5. So for part A, a post box is 140 metres from the library on a bearing of 220 degrees. So let's first of all work out how far this is going to be on our scale drawing. Well, 1 centimetre represents 20 metres. So going from scale to real life, we multiply by 20 and call it metres. So going the other direction, going from real life to scale drawing, we're going to divide by 20 and move it from being metres to centimetres. So 140 metres divided by 20 is going to be represented by 7 centimetres. Now it's got to be on a bearing of 220 degrees from the library. So remember, bearings are always measured from north and always measured in a clockwise direction. So if you've got a 360 degree protractor, you could measure the 220 around here. Or if not, if you've got a normal half moon shaped one, then why not work out the 140 degrees, this angle here, and then pop your line in there. So you put in a working line there, construction line, and then just make sure you go exactly 7 centimetres along to where the post box would be. X marks the spot there. Now for B, part 1, use your scale drawing to find the real distance in metres of the hall from the post box. So I've measured this with a ruler to get 7.7 centimetres. Going from scale drawing to real life, we multiply by 20. So 7.7 centimetres times 20 gives me 154 metres. The answer scheme allows anything between 150 and 158. Now part 2, find the bearing of the hall from the post box. So be careful, it's from the post box. So the hall from the post box. So pop in a north, and then you want to measure around this angle here, all the way around to here, to our line between the post box and the hall. Now probably easiest to work out this acute angle here, which is about 28 degrees, meaning that our bearing, because remember bearing is always measured clockwise, is going to be 360 degrees less the 28 degrees, which is 332 degrees. Now the mark scheme allowed anything between 330 and 334. Question 6. Well, I've started off by working out the size of the interior angles of our regular octagon. Okay, now it's a regular shape, so exterior angles always add up to 360, and because it's regular and it's an 8-sided shape, each exterior angle is going to be 360 divided by 8, which is 45 degrees. And then the interior angle, well, the interior plus the exterior equals 180, so the interior angle of our regular octagon is going to be 180 take away 45, which is 135 degrees. So we know that the interior angle of this octagon is 135, including this angle here, angle KAB is 135. Right, I'm now going to move over to my irregular pentagon. Now, the pentagon's got 5 sides, so that breaks down to being 3 triangles. If I take any point, say from E, and break it down into triangles, I can see I get 3 triangles. So 3 lots of 180 degrees. So the total of my interior angles of this pentagon is 3 lots of 180, which is 540. Now, I know that it's got one line of symmetry. That's why both the angles at E and C were the same at 112. And similarly, these 2 angles down here, the angle EAB and CBA, are both going to be the same angle, which I'm going to call Y. So I know that these 5 angles have to add up to 540. So y plus y, so 2y, plus 112, plus 84, plus another 112 equals 540. So subtracting 112, 84 and 112 from both sides, I get 2y equaling 232. Halve this, I can work out that y is 116 degrees. So this interior angle here is 116. The big angle all the way around here from K to A to B is 135. So my angle X must be the whole angle of 135 less this 116, which is 19 degrees. Question 7. Well, if you're able to break this diagram down, this is fairly straightforward. So what I've gone and done, I've dropped down a perpendicular down here. So I've got a little right angled triangle on the end. I'm going to call this little length here X. This length must be 15 because it's the other side of this rectangle. And this little acute angle here is going to be 125 degrees less than 90 degrees here, so that's 35 degrees. Now using SOHCAHTOA and using tan, I can now work out the length of side X. So I'm going to use opposite and adjacent, so tan 35 equals my opposite side of X divided by my adjacent side of 15. Multiplying both sides by 15, I get X being 15 times tan 35, which is 10.503 dot dot dot. Now I need to work out the length of Y, which is this total length in the bottom. So that's going to be a 37 here, being the other side of this rectangle, plus this length X that I've just worked out to be 10.503, giving me Y being 47.503 dot dot dot. So to 1 decimal place, that's 47.5 centimetres. Question 8. So just think of it as being the 15 divided by 5, the k to the power of 4 divided by the k, and the m cubed divided by the m squared. So 15 divided by 5 is 3. K to the power of 4 divided by k, well, k is to the power of 1. So k to the power of 4 divided by k to the power of 1. When we're dividing, we subtract the powers, so that's k to the power of 3. And similarly, when we're dividing, we subtract the powers. 3 take away 2 is 1, but we don't write m to the power of 1, we just write m. Now for part B, we just need to make some adjustments to have just x left in the middle. So start off by undoing the minus 1 by adding 1 to the 7 and the 17, giving us 8 for x and 18. Then divide both by 4. 8 divided by 4 is 2, and 18 divided by 4 is 9 over 2, 4.5. So x is greater than 2 and less than or equal to 4.5. Well, the quickest way to answer this type of question is using a multiplier. Now, as we've got a 1.5% compound interest rate, our multiplier is going to be 1.015. It's invested for 4 years, so it's to the power of 4, and 6,000 dirham invested. So 6,000 times 1.015 to the power of 4 gives us 6368.18. Now that's the total amount of money in total that Omar will have. So the actual interest is going to be this less the 6,000 that he invested, giving us 368.18, which to the nearest dirham is 368 dirhams. Question 10. So we need to apply this square rooting to each of the components. So it's 16 to the power of a half, x to the 8 to the power of a half, and y to the power of 6 to the power of a half. Now 16 to the power of a half, that means the square root of 16, which is 4. We could just check that on a calculator if we needed to. Now, where we have a power inside the bracket and outside the bracket, we multiply these together. Half of 8 is 4, and half of 6 is 3. Now, for part B, we want to undo this dividing by 3 and this dividing by 2. So we can do this in one go if we choose to multiply each of the 3 terms by 6. So I'm multiplying 8 minus 2x by 6 2x minus 3 by 6, and the 4 by 6. As I've multiplied each of the terms, it is still equal. So the 6 divided by the 3 gives us the 2, and the 6 divided by the 2 gives us 3. So we're left with 2 lots of 8 minus 2x minus 3 lots of 2x minus 3 equaling 24. So I can then do the claw. 2 lots of 8 is 16, 2 lots of minus 2x is minus 4x, minus 3 times 2x is minus 6x, and minus 3 times minus 3 is plus 9. Then gather together like terms. 16 add 9 is 25, minus 4x minus 6x is minus 10x. Now if I then add 10x to both sides and take away 24, I get 10x equaling 1. Divide by 10, I get x being a tenth, or 0.1. Now for part C, I need to make f the subject. So we've got to work our way into f. So we start off by undoing the square root by squaring both sides. So m squared equals a third ef. Now to undo this third, rather than divide by a third, which gets messy, choose to multiply by 3. So 3m squared equals ef. We then divide by e, so f equals 3m squared all over e. Question 11. Now being asked to work out whether these lines are perpendicular. So to start off, I need to work out the gradient of both of these lines. Now with L1, because I've already got it in a formula format, I'm just going to rearrange this so it's in y equals mx plus c format. So I'm going to start off by taking away x from both sides. So 2y equals minus x plus 4. I'm then going to divide through by 2. So y equals minus a half x plus 2, excuse me. So y equals mx plus c. So 2 is where it crosses the y-axis, but the gradient is minus a half. So let's just park that for now. Now with regard to line L2, I don't have a formula, but I've got 2 points on the line, so I can work out the gradient by doing the y step divided by the x step. So take the difference in the y coordinates divided by the difference in the x coordinates. So 9 minus minus 7 is my numerator, and 7 minus minus 1 is my denominator. 9 minus minus 7 is 9 add 7, which is 16, and 7 minus minus 1 is 7 add 1, which is 8. 16 divided by 8 is 2. Now, because when I multiply these two gradients together, I do indeed get minus 1, I can conclude that therefore the lines are perpendicular. If I got any other number rather than minus 1, I would conclude that they are not perpendicular. Question 12. Well, to work out the interquartile range of these results, I've got to start off by putting them in order from lowest to highest, which I've done here. I've then gone and found my middle value, the median value, which is the one in the middle, 5 to the left, 5 to the right, which is 21, and I popped a circle around that. I then go and need to find the middle of the numbers before the 21. So what's the middle of these 5 numbers? Well, it's the 6. And then looking at the numbers after the 21, what's the middle of those 5? Well, it's the 51. So the interquartile range is 51, take away 6, which is 45. Question 13. So both Flavia and Tazia's amounts are being compared to Carlos. So let's just go and say that Carlos gets one lot of money, one share of money. Now Flavia gets 65% of this. So 65% of 1 is 0.65. So let's say Flavia gets 0.65 shares. Now Tazia gets 22% more than Carlos. So that's going to be 1.22 shares. So Flavia 0.65, Carlos 1, Tazia 1.22. In total, adding those three together, that's 2.87 shares. Now, how much money does Carlos get? Well, he gets 1 share out of 2.87. So that's 1 over 2.87. Multiply this by the amount of money being shared, the 861, and I get exactly £300. Question 14. So part 1. So think of 3 to the power of 2x as being 3 to the power of x all squared. Now remember, when we've got a power inside the bracket and outside the bracket, we multiply these together. So that's x times 2 or 2x. So these are the same thing. So we've got 3 to the power of x, which is a, being squared. So that is a squared. Now for part 2, think of this as being 3 to the power of x multiplied by 3 to the power of 4y. Because when we're multiplying, we add the powers. If we add these powers, we get this. Now, think about with regard to the 3 to the power of 4y as being 3 to the power of y all to the power of 4. And again, a power inside and outside the bracket, we multiply these together. So this here is the same thing as 3 to the power of y times 4, 3 to the power of 4y. So once we've got into this format, we can easily substitute a and b in. So 3 to the power of x is a, 3 to the power of y is b. So that's a times b to the power of 4. Similar approach for part 3. Split this down to being 3 to the power of y multiplied by 3 to the power of minus 1. Because when we're multiplying, we add the powers. So we get the y minus 1. Now 3 to the power of minus 1 is a third. So this is 3 to the power of y, which is b times a third. So a third b. Now for part b, I'm going to start off by dividing equation 2 by equation 1. This will mean that my b's eliminate, because b divided by b is 1, and I'm left with a single a, because a squared divided by a is a. So if I can spot to do this, so do equation 2 divided by equation 1, I'm left with a equaling 81. Now, a is 3 to the power of x, so 3 to the power of x, being a, equals 81. 3 to the power of what gives me 81? That is 4. Now I'm now just going to substitute this back into an earlier equation. So I know that AB equals 2187, and I've just worked out that A is 81. So dividing both sides by 81, I get B being 27. Now B is 3 to the power of y. So 3 to the power of y equals 27. 3 to the power of 3 is 27, so y equals 3. Question 15. So, throws the coin 4 times, work out the probability the coin will land heads exactly 3 times. Now, there are 4 ways that you could get heads exactly 3 times when you throw the coin 4 times. The tails could come 4th or 3rd or 2nd or 1st. Now each of these probabilities is going to comprise 3 lots of heads, so 3 lots of 0.3 and a tails of 0.7. So there's no need for me to individually work all of these out. They're all going to be the same 4 numbers, just in a different order. So I've got 4 lots of the same probability. So 4 lots of a heads, 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 tails. Pop that all into the calculator and I get 0.0756. Now with part B, there's a quick way to do this. It says work out the probability that the coin will land heads at least once. Now the only time it won't land heads at least once is when you get 4 tails. That's the only probability we don't want. So if we take this probability away from a whole, we'll get our answer. So it's 1 take away the probability of tails and tails and tails and tails. So 0.7 times 0.7 times 0.7 times 0.7, which gives us 0.7599. Question 16. Now these are fine provided you do things in the correct order and you fill up all the middle ones first. So start off in the very middle. So we need to go right down to this last bit of information. 2 people went swimming, played basketball and used the gym. So that's the first thing we need to do, is put those 2 people in there. Now we then spread out, we fill in these other intersections here. So I've gone to this one next. 3 people went swimming and played basketball. So we've already got 2 who did both of those. So that just leaves us with 1 who did basketball and swimming only. So 3, take away the 2, gives us the 1. I've then moved on to this. 5 people played basketball and used the gym. So basketball and used the gym, 5 in total. Well, we've got 2 already included there. So that leaves us with 3. 5 take away 2 being 3. I've then moved on to 7 people who went swimming and used the gym. So that's going to be this area here. Got 2 already, so that's going to be 7 minus 2 being 5. I can then fill in these bits here in purple. So 28 people went swimming in total. Well, we've already got those 5, 6, 7, 8 swimmers. So that leaves 20 who did just swimming. 16 played basketball. Well, we've already got 6 playing basketball. So that leaves us just with 10 only playing basketball. And 27 people used the gym. Well, we've already got 10 people here using the gym. So 27 take away 10 gives us our 17. Now for part B, one of the people who went swimming is chosen at random. So we're only selecting from the swimmers. And how many swimmers have we got? 25, 26, 27, 28. We've got 28 swimmers. So we're selecting from these 28 swimmers. And we want to find the probability they also played basketball. Well, that could either be this 2 here or this 1 here. So that's 3 out of the 28 people who went swimming. Question 17 part A. So work out the lower bound for the value of P. Now, when you're working out the lower bound of something where it's 2 numbers being times together, to get the lower bound overall, you need both of these to be the lower bound. So we're going to use the lower bound for E and the lower bound for F. So to get the smallest value for P, when you're timesing things together, you want the smallest E and the smallest F. Now the lower bound for E is 4.75. That's the smallest number that rounds up to 4.8. And the lower bound for F is 0.255. That's the lowest number that rounds to 0.26. So 4.75 times 0.255 gives us 1.21125, which to 3 significant figures is 1.21. Now for part B, we're trying to find the upper bound for Q, and we get Q when we divide. Now think about it, when you're dividing 2 numbers, if you want to get the biggest number possible overall, you want to have the biggest number on top divided by the smallest number on the bottom. So we want the upper bound for T and the lowest bound for W. Now the upper bound for T is 2.735 and the lower bound for W is 0.035. Pop that into your calculator, we get this, and this rounded to 2 significant figures is 78. Question 18. Now for part A, the change is inside the function. So this affects the x coordinate but does the opposite to what you would expect. So we're not going to be adding 90 degrees, we're going to be taking away 90 degrees from the x values. So 0, 0 becomes minus 90, 0. 91 becomes 0, 1, and so on. So the whole curve shifts 90 degrees to the left. Now for part B, this is inside the function, so this is going to affect the x value but the opposite to what you would expect. So we're going to be doubling the x coordinate. Now this is outside the function, so this affects the y coordinate but does what we would expect. So we're going to be adding plus 3 to the y value. Now we're talking about the maximum point of the sin curve. So just a quick little sin curve to gather our thoughts. Before we do any transformation, our maximum point is at 91. So we're going to be doubling the x coordinate, so 90 becomes 180, and we're going to be adding 3 onto the y coordinate, while 1 add 3 becomes 4. So question 19, we've got to work out the area of this quadrilateral. So to do this, I'm going to start off by working out the area of this triangle, then the area of this triangle, and then add the two together. So with that top triangle, I need to work out this length here, because I'm going to be using the formula for area of a triangle half AB sin C. So I know the trapped angle, I know this length of this side here, I need to know this length here. Now I can do this using the sine rule because I've got a pair. I know the 9.3 and the 58 degrees, they're opposite each other. So I can say that x over 25 degrees, obviously I knew that was 25 because angles in a triangle add up to 180. So x over sin 25 equals 9.3 over sin 58. That's just using the sine rule. Multiplying both sides by sin 25, I get x being 4.63458. So that's this length here. So I can go and work out the area of triangle ABD by doing half times 9.3 times 4.63458 times sin 97 degrees. Popping that into my calculator, the area of this triangle at the top is 21.390. Now moving on to the triangle below, I have this side, I have question 20. So to write it in that format we need to complete the square. Now to complete the square we need to have a single x squared. So I'm choosing to just factorise the opening two terms. You can factorise all three terms, but I think this is probably a little bit easier. So I'm just choosing to factorise the opening two terms as I've done so here, and then I'm going to complete the square on the x squared minus 4x. So remember, we halve the coefficient of the x, so the minus 4 becomes minus 2. So we have x minus 2 all squared. Now if you picture multiplying out that pair of brackets, x minus 2 times x minus 2, you're going to get x squared minus 4x, which is what we want, but you're also going to get a plus 4 on the end, which we don't want. There's no plus 4 here, so we have to back this out with a minus 4 here. I then multiply both this term and the minus 4 by the 3, giving me 3 lots of this first term. 3 times minus 4 is minus 12, and then I've still got my plus 7. Gathering them together, the minus 12 and the plus 7, I get this as a final answer. So that is now in that format. Now, completing the square allows us to work out the minimum point. The minimum point is going to be when x is 2, because that the bracket then becomes 0. So when because when you square something, the smallest it can be is 0. So our minimum point is at 2, and for what it's worth, minus 5. We've got a positive parabola shape here, so I'm saying the minimum point is at 2 minus 5. So our line of symmetry is going to be going through the 2 minus 5. So this line of symmetry is the line x equals 2. Question 21. So first of all, I'm going to have to work out where this curve intersects this straight line here to find the points A and B. So I start off by multiplying out the pair of brackets in the curve, and that gives me y equals 10x squared plus 7x minus 3. Now, just making y the subject for the straight line, adding 6x to both sides, I can get y equaling 6x. And where does the straight line meet the curve? This will be when I solve the simultaneous equation. So I can substitute in 6x to replace the y. So 6x goes in here. So I've got 6x equaling 10x squared plus 7x minus 3. Rearrange this to set it equal to 0. I get this quadratic equation, which I've factorised here to get 5x plus 3 and 2x minus 1 equaling 0. Now you might be able to do this factorising just by trial and error, by inspection, but here I've set it out the long-winded way. So just to remind you how that works, you say to yourself, what two magic numbers multiply to be the 10 times the minus 3, so minus 30, while at the same time add to be the coefficient of the x, which is plus 1. And those magic numbers are 6 and minus 5. So my next step is to go from these 3 terms to 4 terms, and I just split this 1x into 6x and minus 5x. Doesn't matter which way round, I've chosen to do it this way round. Minus 5x plus 6x equals plus x. I then fully factorise the first 2 terms, giving me 5x times 2x minus 1, and then I fully factorise terms 3 and 4, giving me 3 times 2x minus 1, note the repeated bracket. My pair of brackets to finish then is then the 2 components that are not inside a bracket, the 5x plus 3, and the repeated bracket, the 2x minus 1. So in order for these two together, when you multiply them to equal 0, either the first bracket equals 0 or the second bracket equals 0. So what value of x makes this first bracket equal to 0? We'll take away 3 from both sides, divide by 5, you get x being minus 0.6. And what value of x makes this second bracket 0? That's when x is a half, 0.5. I can then work out the y coordinates by substituting in to the straight line, y equaling 6 lots of whatever x is. So 6 lots of minus 0.6 is minus 3.6, and 6 lots of 0.5 is 3. So I have my 2 coordinates, a and b, minus 0.6, minus 3.6, and 0.5, 3. Now how do I work out the midpoint of this line? Well, I average the x coordinates and I average the y coordinates. So to average the x coordinates, minus 0.6, add 0.5, divide this by 2, I get minus 0.05. And to average the y coordinates, minus 3.6, added to 3, halve this, I get minus 0.3. So, question 22. Now I'm told that A is the point on OP such that the ratio of OA to AP is 3 to 2. So this ratio is 3 to 2. Now I don't know how long they are, but the ratio is 3 to 2. So I'm going to call this length from O to A 3x, and this length from A to P to be 2x, and the same from O to B and B to Q. Now what I'm going to do now is just work out the area of this shaded region from this information here. So how would I work out the area of the shaded part? I would work out the area of the total sector and subtract from that the area of this little white sector. So how would I work out the area of this total sector, OPQ? Well, that would be the proportion of the circle which it is, which is 45 over 360, multiplied by pi r squared. My radius is 5x. Now be careful, that's 5x all squared, so that's 25x squared. Now popping that all into my calculator, I get 25 over 8 pi x squared. And from this, to work out the shaded area, I would subtract from this total sector this small sector here, which would be the same fraction of a circle, 45 over 360, multiplied by pi r squared, pi times 3x all squared. And that is 9 over 8 pi x squared. So when I subtract this, I get 2 pi x squared. So I know the area of the sector is 2 pi x squared. But the question tells me the area of the shaded region is 81 over 2 pi. So this equals this. So I've set this here. Cancel out the pi's, divide by 2 and square root, and I can see that the length of x is 9 over 2. So I can easily work out all the measurements I need to know now. So the question asked me to work out the perimeter of the shaded region. So running around the shaded region. So that's going to be PA, which is 2 lots of x. 2 lots of 4.5 is 9. So there's going to be a 9 and another 9. So 2 9s, but also the length of the arc PQ and the length of the arc AB. So AB plus 9 plus PQ plus 9 will be my total perimeter. So I need to work out the length of the two arcs. So PQ, first of all, that's going to be the proportion of the circle times the times the circumference of the circle. So 45 over 360 times pi times the diameter. The diameter of the total circle would be 10x. So that gives me 45 over 8 pi. That's the length of the arc PQ. Now the length of the arc AB, 45 over 360 times pi times the diameter of that circle, which would be 6x. That gives me 27 pi over, can't read my own writing, over 8. 27 pi over 8. So my total length of this perimeter is 45 over 8 pi plus 27 pi over 8 plus 9 again, giving me a final answer for the perimeter of the shaded region of 9 pi plus 18. Question 23. Now I'm given two pieces of information here. Each allows me to form an equation, and then I have a simultaneous equation which I can solve, which then allows me to work out the fifth term. So how do I get my first equation from this first fact? I'm told that the 10th term of an arithmetic series is 66. Now think how an arithmetic series works. The first term is a. To get the second term, we add on the common difference. And then to get the third term, we add on the common difference again, and so on. So note the difference between the position in the sequence and the number of d's. It's always one less than the position. So for the 10th term, we're going to work that out by being a plus 9 lots of d. So the 10th term being a plus 9d equals 66. So that's my equation number 1, and I've just parked that for now. Now I'm told the sum of the first 20 terms is 1290, and I'm just going to substitute that into the formula which is given at the front of the exam. So the sum of the first 20 terms is n over 2, so 20 over 2 multiplied by 2a plus 20 minus 1 multiplied by d, and all of that equals 1290. So 20 over 2 is 10, 20 minus 1 is 19, giving me this. Divide through by 10, I get 2a plus 19d equaling 129. Now there's my second equation. So I've now got a simultaneous equation to solve. Now I'm going to line up the a's by choosing to double this equation 1. So doubling this, I get 2a plus 18d equals 132. And line that up next to equation 2. If I now choose to subtract equation 2 from this doubled equation 1, I get 2a minus 2a is nothing. 18d minus 19d is minus d. And 132 minus 129 is 3. So d equals minus 3. Now substituting d being minus 3 back into equation 1, I get a plus 9 lots of minus 3 equals 66. So a minus 27 is 66. So a is 93. So I know that d is minus 3 and a is 93. Now just following what we did earlier on here, to work out the fifth term, it's going to be a plus 4 lots of d. So a is 93 plus 4 lots of d, which is minus 3. 93 plus 4 lots of minus 3 is 93 subtract 12, giving us a final answer of 81.